All right, this is day 7, and this is going to be something you've never seen before, never heard of before. Possibly a concept that will be a little difficult for you, but I'll try to make it as simple as possible. So, don't overthink it. I think is part of it too. So, our learning target is I can identify the log, which is actually a logarithm. That's short for logarithm. I can identify the logarithm function as the inverse of an exponential. I can convert from the logarithm to exponential form. So we've done a lot with exponential form, but now we're going to go to a thing called a logarithm form. And I can solve basic log equations by guess and check. So just real quick, reminder of what inverse is. Okay, so find the inverse of each parent function in y equals form if possible. So we're going to find the inverse. If you remember, inverses are functions whose x's and y's are switched. Okay. They're the exact opposite. So if you made a t-table, the x's of one function would be the y's of the other function. The y's of the first function would be the x's of the second function. So they literally have the exact opposite x and y coordinates that make them that are solutions to their equations. So first off, on this one, if you remember this, to find the inverse, you're going to switch the x and the y. So like this first one here, if this is the original function, to find the inverse, I'm going to switch the x and the y. So I'd have y squared equals x, and I want to solve and get y by itself. To get y by itself, I take the square root. So y equals the square root of x. Within reason, this is the inverse function. There are some numbers this doesn't work with, just because there's some negatives involved in there. But this is the inverse function of it. I know we really should put plus minus in there, because when you square, you got plus and minus. Talking about the cubed, okay? Whenever we're cubing, we'll switch these. So x equals y cubed. So I switch the x and the y, now cube root. So y would equal the cube root of x. So a cube root and a cube are inverses, just like a squared and a square root are inverses. This one's kind of a weird one. Y equals x. Now if I switch that, if I put the x here and the y there and then solve for y, it is by itself. So y equals x is actually the inverse of y equals x. Think all the coordinates for this. If y equals x, if I make a t-table, plug in 2. If I plug in 2 for x, y is 2. If I plug in 3, y is 3. If I plug in 7, y is 7. Now flip those, it's the exact same thing. That one it's one of the few functions that it is its own inverse. This guy here, if I switch them, so x goes here, y goes here, and I want to get y by itself, so I would square both sides to get y by itself. Well, look at there. So the inverse of square root is squared. Up here we said the inverse of square root of square was square root. Well, they're inverses of each other. This guy here, this is the reciprocal function. We will study that in I think unit 9, might be unit 8, I can't remember which. I think it's unit 9. But let's flip-flop those. So x equals 1 over y. Now solve for y. So if I solve for y, and multiply both sides by y. So yx equals 1. Now divide by x. So y would equal 1 over x. So there's another situation where it is its own inverse, because y equals 1 over x and y equals 1 over x. How about an exponential? Okay, so this is the one where what's the inverse of an exponential? We really haven't talked about that. If I switch the x and the y and I said solve for it, there's really nothing to do with this. So that's what today's lesson is all about. So if I were to switch the x and the y, and I make this x equals 2 to the y, and I said, how do I get the y out of the exponent? I want to solve for y. That's where the logarithms come in. Okay, so what we do, a log, if I took log, and this is how it's read log base 2 of x would equal, and if I do log base 2 like that, this actually cancels out, and it's y equals log base 2 of x. So that probably made no sense to you, and that's okay. The next few days is all about understanding what in the world I just did. Okay, but the important thing here, this log and this x are like, if you're writing, those are normal on the think superscript, subscript. Well, log and x are normal. 2 is a subscript, and then y is normal. So these three things are all in the normal line of writing. 2 is a subscript down below. Some students think that it's like it's log 2, and then x is the exponent, which would be a superscript. That's not it. It's the 2 is actually down below, and the x is on the same level as a log. So this notation is just saying, well, let me do the definition. So the definition of logarithm, as long, now we have to have this b has to be greater than 1. Okay, so as long as b is greater than 1 and b is not equal to 1. Okay, so it has to be anything larger than 1 besides 1. Log base b of x equals y. So when I read that, I'd say log base b of x equals y. It's like this right here. That's how you say that out loud. Log base b of x equals y. This is true if, and only if, b to the y equals x. So the base, let's say this is the base of an exponential, and that's the exponent. If I took b to the y power, that should equal whatever's in the x. And on these, a lot of these will all be numbers. We'll fill them in, or we might give you the b and the x and have to tell you to solve for y, or we'll take one of them out. But for the first few, we gave you all the numbers to show you what it should look like and how to convert it, and we're going to convert it to exponential form. One thing that might be helpful also is a logarithm. A logarithm is equal to an exponent. So when we say this right here, the y is actually the exponent. The b is the base, the y is the exponent. X is what you get when you multiply them. Okay, so it sounds weird. There's a reason why we write like that, though. So for this one here, it says convert to the exponential equivalent. So exponential means there has to be a base and an exponent. Well, on this one, the base is 2, and then a logarithm equals an exponent. So whatever it equals is the exponent. And then whatever this, the of, log base 2 of 8, that's supposed to be the answer of the exponential. So basically, 2 to the third equals 8. 5 squared equals 25. In this one, 10 to the fourth equals 10,000, and that's true. So if it's a problem like this, on a quiz even, if we give you something like this, and we say just convert it to the exponential form, give you all the numbers, make sure this is a true statement. 2 to the third is 8, 5 squared is 25. Make sure it actually makes sense. Now we're trying to convert the following back to logarithms. So these are exponentials. I'm going to go back to the logarithmic form. So log, and then what's the base? So look at this. Which one of these numbers is considered the base? 3. So 3 is a small 3, a small subscript, of, and this is supposed to be the answer. So 27 equals, and then the exponent always goes on the other side. So log base 3 of 27 equals x. Now you could answer that. What would be the answer of that? If I said answer it, well, what does that equal? In fact, we'll do it down here. So see, log base 3 of 27 equals x. This says solve for x. Well, maybe we'll hold on to that for a second. If you think you know the answer, write it down here, and we'll see if you're right. Okay, this one here, log, what's the base? The base is 10. What's the answer? 1 equals 0. So log base 10 of 1 equals 0. Now we do have a special name for when the base is 10, but we'll talk about that on the back. Okay, we'll talk about that more when we get to the back. Sometimes I like to do this on a quiz just to see if you really know what you're doing. That way you can't just plug stuff into a calculator and try to find a roundabout way of answering it. We want to know, do you really understand? So log, and what's the base? The base is m. The answer was k, and that equals p. Okay? So again, m's a subscript. Everything else is on a normal level line of writing. Okay, so let's go down here. Let's answer this guy. So what it's asking you right here, when it says this, it's saying 3 to some exponent equals 27. What is that exponent? Okay, so 3 to what power equals 27? So 3 to some power equals 27. What is that power? It would be 3. Because 3 times 3 times 3, if you multiply it by itself 3 times, the exponent is 3. This guy here is saying the base is 5, the exponent is x, and the answer should be 125. What are you multiplying 5? What are you raising 5 to? What power is that? Well, x would be 3. Over here, what base raised to the second power equals 100? That's what this is asking. So what number squared is 100? Whoops, I put 1,000. Just 100. I copied it down wrong. So what squared equals 100? 10. And that should be 10. You might be thinking, why wouldn't I do negative 10 there? Remember, b, the base, we do logarithms when the base is larger than 0 and not equal to 1. So we had to, for that one, we only did the positive. This guy here, base is 5, exponent is 3. And what's the answer? Well, 5 to the third. 5 times 5 times 5 is 125. What number to the fourth? This is what base to the fourth power equals 81. So what times itself? 4 times equals 81. Well, that would be 3. Okay. 100 is a base. 100 to what exponent equals 10? Well, how do I get a smaller number if I'm multiplying? Well, that means that this number here, it's a fractional exponent. Okay, so if you remember taking things, because really, how do I get from 100 to 10 using powers? Well, it would be a square root, right? Well, square rooting is a 1/2 power, so this one is going to be a 1/2. So if you notice the base is bigger than the answer, you probably have a fractional, or it could even be a negative in some cases, a negative exponent. So those, keep in mind the different ways we can get smaller answers than we have bases. Okay, let's go to the back side. Looks like I get a little bit faster now on these, especially the next 6, but we kind of know what's going on. So this guy, this is saying, and if you want to, you can pause the video and try these 6. Just quickly do it. You can, if you really understand what's going on, you can probably do these in like a minute, minute and a half. You can do these 6 problems, and then just kind of fast forward the video and see if you got them right. But this one here, base is 2, the exponent is x, so 2 to what power equals 32? Well, what power do you raise 2 to get 32? That'd be 5. Here, base is 9, the exponent 0, and that equals what? Well, that equals 1, because anything to the 0 power equals 1. Doesn't matter what the base is. If that equals 0, that equals 1 every time. Here the base is 2. I don't know what the exponent is, but I need to get 1/8 as an answer. How can I get a fraction when I have a whole number base? Remember, that's negative exponents, flip them over. So first off, if x was negative, that would flip this over. It'd be 1/2, and it's 2 to the third power gives you 8. So if I do 2 to the negative third, that would negative flips it over, third power makes it 8. This guy here, base is 6, x is the exponent. Now, what would I need to raise that to get 0? Think about that really hard, because I got a positive number, I'm multiplying a positive number times itself over and over and over. Can I ever get nothing? That can't happen. Yep, so if this argument, we call that the argument, if that's ever 0, nothing can do that. Okay, so there's no solution. We'll try to sneak those in on you every now and then, so be careful. This one here, base is 2, exponent's 4, and we want to know the answer. Well, 2 to the 4th is 16. Here, base is 2, the exponent is 1/2, and what does that equal? Or 2 to the 1/2 is like square rooting. So we could just say the square root of 2 equals x. We'll keep whole numbers. Okay, now, these guys, we have special names. Certain kind of logarithms have certain names because they're so frequent, we use them so much. One of them is called the common log. Okay, and the common log is a logarithm that has a base of 10. So if the base is 10, like that, they got tired of writing 10 over and over, because we use 10 a lot, like when you're talking about scientific notation, if you're talking about how the distance between things in space or something like that, use a base of 10 a lot. So this was so common, they just said, you know what, just stop writing the 10. So if you see this, that means the base is 10. Okay, and this is sort of like they use on the Richter scale too, like earthquakes. When earthquakes happen, if there was an earthquake, some earthquake was, if we were going to compare, maybe there's an earthquake in one part of the country, compare, it should be a P in there, no? Compare. So compare, if we're comparing a 4 to a 3 on the Richter scale, you'd say, well, that's a little bit bigger. No, it's actually 10 times bigger, because a Richter scale uses a base of 10. So whatever they're measuring, it's some kind of amount of energy that's released by this earthquake. If it's a 3, that's like 10 to the third power. If it's a 4, it's 10 to the fourth power. So that's 10 times bigger. So the 4 is 10 times stronger. Okay, it's going to be 10 times stronger. Just like if we, well, I kind of get the idea. So with the Richter scale, it uses that. So if you ever hear like you know, a 10 point or a 4.1 compared to 4.2, that's a big difference. You know, it's not just 0.1 bigger. You know, it has to do with an exponent of 10, you know, being 10 times stronger. Another base they got so sick of using, they got sick of writing, was the base e. So instead of writing log base e of x, because they noticed, like in a lot of science stuff, you have base e, and you have to use a logarithm to get rid of that base of e, because remember, logarithms are inverses of exponentials. We're going to use this to solve some exponential problems. They got used to using that so much, they said, I'm tired of writing it, I'm just going to call up a natural log. And so there's no base written, it just says ln of x. That means log base e of x. That means the base is e, okay? So if anybody asks me this in class, what's that mean? I'm going to say, you didn't watch your video, did you? Because right here I'm telling you exactly what it is, okay? So this is how they'll be written in problems. Common log, natural log, okay? Now, let's do some of these in our heads. Now this one has a base of 7. So neither one of those common ones. This says 7 to what power equals 49? Okay, and that's 2. This says common log of 1,000. So it's not written, but it's asking 10 to what power equals 1,000? Well, that's 3. Okay. 3 to what power equals 27? That'd be a 3. 2 to what power equals 0? Be careful, can't do it. So no solution. Remember, I can't take a positive base and multiply it by itself and get 0. Can't happen. 8 to what power equals 1? 8 to what power? So anything to what power equals 1 would be a 0 power. So anytime you see log of anything, or sorry, log base anything of 1, that being a 1 there, that's your answer. The only way we get 1 for an answer is if the exponent is 0. Natural log of e, it looks weird, but it's really, this is a fancy way of saying log base e of e. Okay, that's what I'm thinking. So e to what power equals e? 1. So anytime you see natural log of e, it's 1. Or if you see the common log, if I just said log 10, that also equals 1, because 10 to what power equals 10? Okay, so some more interesting ones here, just to kind of handle some of these trick ones. I'll go a little fast. My video's getting long here, but common logs, the base is 10. So 10 to what power equals 1 over 100? Well, in order to make it a fraction, I got to flip it over with a negative, and then go from 10 to 100, I have to square it. So negative 2. This one here, this is saying 9 to what power equals, and I can write that as a 9 to the 1/5. Remember how the fifth root of something, exponent's 1, root's 5, so you can write it as a fraction, 1/5. So that means x is 1/5. Because 9 to the what power equals 9 to the 1/5? 1/5. Okay, this guy here, the base is 10, so 10 to some power equals, and if I want to rewrite this, that's actually a square root. This would be 10 to the 3 over 2. That's what this argument is 10 to the 3/2 power. So 10 to the x equals 10 to the 3/2, well, that'd be 3/2. This guy here, natural log, that means the base is e. E to what power equals, and I could rewrite this argument as e to the negative-5th. You know, it's 1 over e to the positive 5. We'll flip it over. That means x is negative 5. 243 to what power equals 9? Okay, now to get it down, you're going to have to, it's going to be a fractional power. Now, it's not a fraction. Now, the answer is not a fraction, so I don't want to flip it over. I don't want any negatives, but I will have to have a fraction. So you kind of think to yourself, what's a base that they would share? You know, like I can't take 9 to any power and get 243. If I take 9 times 9, I get 81. If I take 9 to the 3rd, I get 729. So 243 is not really like a multiple of the exponent. It's not really a multiple, but if I start multiplying 9 by itself, I don't get 243 ever. But they both can be written with a base of 3. So I could write 9 as a base, as 3 squared. I could write 243. I'm going to take out 243, and I could write that as 3 to the 5th. And you can do that by guessing and checking. Just take 3 times 3 times 3, and take out times 3, and then take out times 3 until you get 243, and oh, it took 5 times. So this would be 3 to the 5x, because power to power means multiply, equals 3 squared. Well, if the bases match, what do I multiply 5x by to get 2? So 5x equals 2 divided by 5, so the x by itself, so it'll be 2/5. So take 243 to the 2/5 power and you'll get 9. Over here, kind of same idea. 81 is my base. I can't take 27 squared. That's going to be way more than 81. So it's not going to work that way, but I got to find a shared base. Well, I could use 3. So 3 cubed will give me 27. 3 to the 4th gives me 81. So that means 3 to the 4x equals 3 to the 3rd. So that means 4x equals 3. Divide both sides by 4. So x is 3/4. You can always check it by up here. Take 81 to the 3/4 power and you get 27. Okay. So video got kind of long. Hopefully you were able to, at some points, fast forward a little bit. Maybe you tried a few on your own, and that's great. But if you have any questions, let me know.